Well, kid, just when I was getting to like you, this is our last visit. I've taught you all I can. Now it's time for you to get out there on your own. But before you go, let's review this last phase you went through, the control phase. In Step 10, you started learning about the components of a process control system, including the need for an implementation plan, documentation and training, as well as the requirement that you reevaluate process capability to confirm the improvements. And you were reminded that if there is a measurement system for the project improvements, it should be validated before going any further with the implementation. Then in Step 11, you reviewed the process capability analysis. In order to statistically confirm the improvements, it should be completed both in the pilot and once the improved process is fully implemented. Finally, in Step 12, you completed the process control system by choosing between a risk management system, mistake proofing, and statistical process control charting. That was a quick summary of the key steps in control. If you want further review, you can access all of the steps from the control menu at the top of the screen. And the resources, glossary, and tools can be found in the left-hand menu. Select all that apply. Okay, that was pretty easy. That was just a warm-up to get you thinking. Click Next for question number 2. You did measurement system validation back in Step 3. What best describes the reason you are doing it again? That's right. The key difference between the steps is that Step 3 is focused on the project Y and Step 10 on the project X. Click Next for another question. Remember these. Here are 2 process capability reports for a Six Sigma Green Belt project before and after the process changes have been made. Did the improvements have the desired effect? You got it. The defects per million opportunities has actually increased, so the process is definitely not improved. Click Next to continue. If you performed a hypothesis test to confirm improvements on the same process that you just saw the capability results for, what do you guess that outcome would be? Excellent! The test would be set up with the alternative hypothesis, being there is a difference after improvements, and the null being there is no difference. In the previous capability results, there was very little change before and after improvements, so the alternative would be rejected. What is mistake proofing? Select the best description. Sure. Mistake proofing is controlling process by finding a way to make mistakes impossible. Click Next for your next question. For your last question, look at the chart and indicate if the process is going out of control. Then click Done. Good job! The control chart shown on screen indicates only random variation in the process. Click Next to finish the review. So, do you have it all under control, pal? Take a look at your score on the questions. If you missed a couple, you may want to go back through the steps again before moving on. When you feel like you're ready, click Next to go to the course. Let's take a final look at the loan sales case through the lens of the Six Sigma DMAIC process. We'll look at each phase and see how it links with what we accomplished in the GE Commercial Loan Sales Office. The three main deliverables for the define phase were the customer CTQs, or critical to quality factors, the team charter, and the high-level process map. Click on each of these items for more about the loan sales case. When you're done, click Next to continue. The customer critical to quality items drive the entire project. In this case, we identified the various businesses requiring loans as our external customer and their primary CTQ as the on-time delivery of funds on the request date. Click on Return to return to the defined summary. The team charter covered a number of elements of the loan sales case. The business case is stated from a GE viewpoint, that sales are declining due to the customer's uncertainty about receiving cash on time. The problem statement identifies what we wish to avoid. In this case, those customer complaints. The goal statement is a high-level statement of what will satisfy the customer CTQs, bringing the range of delivery times closer to the target of on-time delivery within the next 6 months. The scope of our project will include the loan approval process, but will not include the funds disbursement process or collections. The team is simply a list of those involved in the project. Click on Return to go back to the Define Summary page. Our final exercise in the Define phase was to follow the COPUS model. First, you define the customer as the various businesses that need funds. The output for the process is on-time delivery of cash. Loan approval and disbursement are two processes. The input is a completed loan application package. The supplier, of course, is any GE commercial loan business. This high-level process map is designed to put the customer first. Click Return to go back to the Define Summary page. In the Measure phase, we drilled down from the customer CTQ to find a specific improvement we could use to address the larger issue. We then developed a performance standard for that process and validated the measurement system used to collect the data. Click on each of these to see more detail concerning the loan sales. We chose from among a broad assortment of tools that included the FMEA, Fishbone, and QFD, starting with the customer CTQ of on-time delivery of funds. We drilled down to more and more specific processes. We discovered that the cycle time for loan application processing was a good possibility for improvement. Within that process, credit check process was a major contributor of rework. The final analysis determined that the application data entry process gave us the best chance of accomplishing a major improvement by addressing a small part of the overall process. So this became our project CTQ. Click on Return to go back to the Measure Summary page. Our next task was to define our performance standard. A good performance standard includes an operational definition of the process, target performance, specification limits, and a defect definition. In this case, the operational definition was from the time the form is received by the associate to the time it is ready to be submitted to the credit bureau. The ideal performance is 48 hours. The upper spec limit is 72 hours, and the lower spec limit is 24 hours. That makes a defect any time under 24 hours or over 72. Click Return to go back to the Measure Summary screen. We conducted a gauge R&R to aid in our measurement system validation. We had the forms available to us from the past year, so we used 10 forms randomly selected from that historical data and numbered them from 1 to 10. The data was stored in a Minitab worksheet, and the gauge R&R results showed that the measurement system was valid. Click Return to go back to the Measure Summary page. In the Analyze phase, we use that data to establish our process capability, or benchmark, to determine our current process performance and potential. We then use the process capability to determine our performance objectives for the project. Finally, we brainstormed a list of possible sources of variation in our process. Click on any of the items to see more about it. The Process Capability Report provides a number of vital pieces of data for the Six Sigma project leader. The capability indices provide long-term and short-term z-values and the number of defects per million opportunities. In this case, we found that we had over 217,000 defects per million opportunities, which was absolutely unacceptable. Click on Return to go back to the Analyze Summary page. By comparing our process with that of benchmark competitors and taking into account our own process capability, we set the performance objective as reduction of the long-term DPMO of the application data entry process from over 217,000 to under 40,000 defects per million opportunities. Because the performance objective DPMO is less than our estimated process entitlement, we will look for a change in process technology, which could include new forms, a change in style, or other systemic changes to the application and/or the way we enter the data. Click on Return to go back to the Analyze Summary page. After using a two-sample t-test to confirm the significance of the difference between our process and that of our competitor, we used a cause and effect diagram, also called a fishbone, to assist in brainstorming potential sources of variation, or vital X's. Click on Return to go back to the Analyze Summary page. In the Improve phase, we started by screening the potential causes brainstormed at the end of the Analyze phase. We then validated the relationships between the factors and our project goals. This led to a proposed solution for our project. Finally, we discussed additional tools which, while not applicable to this particular case, could be of use in other circumstances. By conducting a screening DOE and examining the generated p-values, we discovered that the application type, field highlighting, and the interaction of application type and field highlighting had p-values of less than 0.05 and were therefore the vital X's. Click on Return to go back to the Improve Summary page. In Step 8, we discussed the circumstances under which optimizing DOEs and additional regression analysis would be necessary. We also discussed why they were not necessary in this situation. We discussed the equation which allows us to directly calculate the targeted change required to meet our project goal. Click on Return to go back to the Improve Summary page. In this final step of the Improve phase, we provided an introduction to the concept of statistical tolerancing. Click on Return to go back to the Improve Summary page. Once we have determined what our solution will be, we must make sure that we implement it properly. To begin with, if there is a new measurement system for the vital X's, we must validate it. We must also generate a process capability report for the improved process to verify that we have met our project goals. Finally, we must place adequate controls on the process to verify that the changes are implemented and continue. Click on each of these items in turn to see additional information. Then, click Next for instructions on how to complete this course. In the Control phase, you used the same measurement system analysis checklist used in the Measure phase for the same purpose, to validate your measurement system. In our loan sales case, we have discrete X's that don't require a new measurement system to collect data. However, because of our improvements, there was a slight change in the measurement system for collecting the Y data. So we used the checklist to revalidate that system. Click Return to go back to the Control Summary page. Well. We improved our sigma score by about a half a sigma. But the key number to note is that DPMO has dropped from around 217,000 to just over 24,000. Click Return to go back to the control summary page. Finally, we were able to finalize our process control system for the GE Commercial Loan Sales Office. We determined our process controls by finding a way to mistake-proof both of the X's. We established that the new process must be documented and the staff involved, such as the data entry associates, should be trained. And we confirmed our data collection plan to continually monitor our process capability. Click Return to go back to the control summary page.